Hello, welcome to Flip. So today we are on alcohols. These are the learning objectives for today. And this is actually the third group we'll be looking at after what we learned for alkanes and alkenes. Okay, if you recall how they look like, they both look like this. Okay, with a C with 4 bonds around it, recall. And for alkenes, it has 4 bonds around it as well, but it only has 3 bonding regions, okay, to bond around it. Alcohol looks a little similar to alkanes, okay? I'll show you how they look like later. But let me just go through some of their the facts, okay? Alcohol is not a hydrocarbon because based on its general formula is CnH, okay, 2n plus 1, okay, OH. Alright, then its functional group obviously is the OH group. Do you recall that for alkenes, the functional group is this double bond here? So for alcohol, the functional group is OH. Okay, so because hydrocarbon means it only has hydro, which is hydrogen, and carbon, alcohol is not a hydrocarbon because it consists of oxygen atom here. Okay, that's why it's not a hydrocarbon. Okay, let's move on to the naming portion of it. Okay, so if you recall, we have the naming system for organic compounds in terms of the number of carbons, 1, 2, 3, and 4 carbons. Am I right? If it has 1 carbon, it's called meth. If it has 2, it's called F. 3 will be prop. 4 is but. Alright? So, in the case of alcohol, it's methanol, ethanol, propanol, butanol. Okay, so it's the same thing. 1, 2, 3, 4 carbons. Okay, formula will be general formula. It's here. Okay, let me just write it here again. CnH 2n plus 1 OH. Am I right? So if you sub in let's do one by one. If it's sub in carbon as 1, okay, so we sub in 1 here, you will get CH3OH. Okay, do not combine the H with this, so do not write CH4O because this OH should stand alone on its own because it's a functional group. Okay, so next one will be C2H5OH. Okay, next one will be C3H7OH. Finally, butanol, it's C4H9OH. Okay, so they all end with OH, 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 OH. Okay, because it's the functional group. Structure-wise, it's very similar to alkanes, like I said. It's because it looks like this. Start with the C, okay, and OH. Okay, that's all. The rest you fill in with hydrogens. H, H, H. Okay, if it's 2 carbon, just simply continue with 1 more carbon here. We've end it with oxygen, OH. The rest is just hydrogen again. Okay, let me draw the final 2. So, final 2, if it's 3 carbon, it's the same 1, 2, 3. With an OH to end it off. The rest fill in with hydrogens. Okay, so you can see it looks really like alkanes in the sense that everybody, it's a single bond. Okay, there's no double bond involved here. Finally, for butanol, it's the same with 4 C's. Okay, the rest it's just hydrogen. Okay, you can always do a check to tally the number of carbons, hydrogens, and the OH. Okay, it should match the formula. Okay, hopefully it's clear. Okay, now let's move on to its properties. So the properties of alcohol is that it's very similar to alkenes and alkenes in the sense that as the number of C increase, okay, viscosity, melting point, boiling point will increase, flammability will decrease, okay, because this one, it's simply put, it becomes heavier, harder to burn, and that's why flammability decreases. Okay, this is all in our alkanes and alkenes chapter. You can check it out if you are not very sure for this portion. But the only difference, I would say that alcohol, compared to alkanes and alkenes, is that, okay, we just write it here, alcohol has higher melting point and boiling point than alkanes and alkenes. Okay, so that's the only difference between them. Other than that, the trend is similar. Okay, in that these three things will increase, flammability decreases. Let's move on to the reaction portion. Okay, so for alcohol, you have to remember there are two reactions. One being combustion, second one being oxidation. Let's start with the combustion first. Okay, as with all organic compounds, okay, alcohol can combust. Means it can burn, right? So first one, it's complete combustion. Second one is incomplete combustion. Okay, we have gone through this many times. Okay, you can find the general formula, the equation for the combustion in our alkenes video. But just to give you an example for each, okay, I will just write it down here. Complete combustion, if for example I were to use ethanol, C2H5O6, okay, ethanol, because it has 2 carbons, am I right? Ethanol with 3 oxygen, giving me 2 carbon dioxide plus 3 water. Okay, this is complete combustion, because for complete combustion, the only 2 products are carbon dioxide and water. On the other hand, if it's incomplete combustion, okay, using ethanol again, okay, now with 2 units of oxygen, you can see now that my product is 2 carbon monoxide and 3 water. Okay, so that's the difference. Of course, that it does not end here with incomplete combustion, because incomplete combustion, like I told you, can produce carbon monoxide, and carbon dioxide. Okay, this is just one example of what it can produce. Okay, which is carbon monoxide and water. Whereas for complete combustion, these two won't change. Okay, it's the same throughout. Water and carbon dioxide will not change. Okay, hopefully it helps. Let's move on to the next part, which is oxidation. Okay, oxidation is something you haven't really seen before yet in this whole organic portion. But basically, oxidation is really just a reaction with oxygen atom. Okay, be clear about that, because look at this. Combustion is reaction with oxygen molecule, the gas O2. But in this case, it's with oxygen atom. Okay, I'll explain what is going on here with an equation. Okay, but first you have to understand that there are a few ways to oxidize alcohol. First one is using acidified potassium manganate 7. This one you have to memorize, or using acidified potassium dichromate 5. Okay, this is one way, or you can just put it in air. Basically, you just put your alcohol here and leave it open, basically. Okay, then the air contains oxygen molecules and it will oxidize this alcohol right here. Okay, let me just give you an equation to illustrate this point. So, for example, I use back ethanol, C2H5OH plus. Okay, you'll notice that now my writing is different. I have this square bracket to encapsulate this oxygen to give me CH3COOH plus H2O. Okay, so this is the symbol for oxidation, this square bracket right here. Okay, and only alcohol can undergo oxidation. Okay, so far, compared to alkanes and alkenes, and you will get an acid here. Okay, we will talk about it in the next chapter actually. Okay, so alcohol plus oxygen, not atom, oxygen atom but not oxygen gas, will give you a carboxylic acid. Okay, next we will talk about its formation. First, it's hydration. So hydration takes place at 300 degrees Celsius in the presence of phosphoric acid. Okay, phosphoric acid acts as the catalyst. Okay, this is very similar to the alkenes reaction. Okay, so this is actually alkenes reaction. Okay, because we are here forming ethanol. So what we take is, we take a ethene molecule actually, we add it with a water molecule, giving us what we want, which is ethanol here. Okay, so don't be confused, because just now we were talking about the reactions of ethanol. But now we are talking about how to form ethanol. Okay, so that's the difference. So in this case, we're actually using an alkene, okay, with water to form an ethanol molecule. Okay, another way to form ethanol, okay, is using 37 degrees Celsius, which is actually room temperature, with yeast and glucose, okay, which is sugar. Okay, so this is really just like a baking process. Okay, what you do is you take this is glucose. Okay, it will form okay, it will form 2C6. Oh, sorry, this is not 2. This is actually 6. Okay, C6H12O6, giving me 2 C2. Okay, let me just rewrite this. This is very ugly. Okay, sorry about this. It will take a glucose molecule, C6H12O6, okay, to give me 2C2H5OH plus 2 units of carbon dioxide. And if you can see, this is ethanol. Okay, it's just written out in a molecular formula instead of being drawn out, but they are the same thing. Okay, so there are two ways to form ethanol. One is using hydration, adding water. Second one is to ferment glucose, basically breaking down glucose molecule. Okay, that's the meaning of fermentation. Okay, into ethanol for different uses, which we'll talk about right here. Okay, so ethanol, there are 3 uses you have to recall. Okay, you can just ignore all the facts that they give you. Just recall 3 things. Okay, it should simplify your learning. First one, it acts as a solvent. Second one, it acts as a fuel. Finally, it acts as a alcoholic beverage. Okay, like vodka, etc. Okay, and that is all for ethanol. That is all for alcohol component.